Today we're going to look at caves, arches, stacks and stumps. And the two examples to explain this are Old Harry rocks, which is over here. This is Old Harry, a stack on the Jurassic coastline, South Dorset, and then just further west along the coast, Geological, which is over here, which is a arch. So let's see how these two landforms are formed. Well, first of all, the conditions for these landforms are they form on headlands where there's resistant rock, and in this case we're talking about chalk for Old Harry, and Portland limestone for Geological. And the Old Harry is about 12 metres high in terms of scale and size. So that's what they're made of. They are well jointed, lots of joints and bedding planes. And that's very important, as we're about to discover. So they are the conditions. What happens? Well, first of all, where you have joints in the rock and chalk, these are eroded by marine erosion, particularly hydraulic action. So in here, we've got hydraulic action. And as waves crash against the cliff and the joints, air is compressed into the joints, and it's put under a lot of pressure. And as the wave retreats, there's that release of pressure, and there's like a mini explosion. And as this happens, repeated over a long period of time, eventually fragments break off, and these joints are slowly eroding, become larger and larger, until they start to form caves. And they're also further further sort of enlarged by weathering processes such as salt crystallization and wetting and drying. So these are the weathering processes and erosion processes that are widening these joints to form caves. The next step is the caves get larger and larger until it creates an arch. And Geological is our example here. And the caves get larger and larger until it breaks through the headlands through to the other side. So you can see right through that cave, and it's all due to the process of hydraulic action, salt crystallization, wetting and drying. And because it's a headland, you have wave refraction that is concentrating wave energy on the headland. Now, once these caves and arches start to form, abrasion becomes more significant, and that works the sandpapering effect at the base of the arch, of the material that's carried by the waves and crashing against it and scraping it, and that slowly develops these wave-cut notches. And as a result, the arch widens and widens, and until the point where the overhang that overhang here can no longer be supported. And what happens eventually, when the arch gets wide enough, the overhang collapses. And what happens, and what you see next, is a stack. An isolated piece of rock, now separate from the headland. And at the base you have the collapsed rock that will slowly be broken down through attrition and removed by wave energy. And the stack and the headland continue to be eroded, and by joints and weaknesses in the rock, undermining, working away on them, but also at the base, wave-cut notches here slowly being eroded and thinned. And as a result, this stack will slowly get thinner and thinner as the sides start to overhang over these wave-cut notches, and these sides will collapse down, and slowly you get this parallel retreat. Of the stack, and it will get thinner and thinner until it becomes more like this. Now lastly, the last stage is where the stack eventually collapses. Again, there's overhang on the stack, and it can no longer be supported, and often in sort of storms such as in 1896, Old Harry's wife, he used to have a wife, collapsed, and this is Old Harry's wife that collapsed in the storms, and that it's because the storms have the high energy destructive waves that do the most damage and erosion on the coastline. And so we're left with this stump. This stump is only exposed at low tide. So this is the high tide mark here, this is the low tide mark. And so you only see Old Harry's wife, a stump that's a sort of collapsed stack at low tide. So that's how caves, arches, stacks and stumps are formed.